Hi everyone, this is Andrew Fobberg and you are watching Fobberg Reviews. We test what are the trust. Today we are taking a close look at Tenon Refractory Mortar, a pre-blended high-heat masonry mix designed for fireplace, stoves and chimneys. We'll unpack it, mix it, apply it and tell you exactly where it performs well and where it may fall short. Let's get started. The product comes in a sealed 10 pounds, 4.45 kg plastic bucket, compact, durable and easy to store. The label provides key specifications: heat resistant up to 2550 Fahrenheit, 1400 Celsius, water and exit resistance once fully cured, classified as medium duty refractory mortar. There is not clearly printed manufacturer's date. Instead, there is a code on the lid, 25045, which is most likely a Julian date, meaning the 45th day of 2025. That kind of coding may be fine for industrial buyers, but it's not very user-friendly for the average customer. The manufacturer provides both a technical datasheet and safety datasheet, both available online. According to the documentation, the mix contained calcium aluminate cement as the main binder and crystalline silica. The SDS includes several safety warnings. The product can cause skin and eye irritation. It may be carcinogenic if dust is inhaled over a long period. It falls under California Prop 65 warnings. Always use proper PPE, gloves and respirator or dust mask and eye protection when handling the dry mix. Tenon Refractory Mortar is a dry, prepackaged masonry mortar formulated with calcium aluminate cement. As its primary binder, this gives it excellent thermal stability and chemical resistance after curing. It's engineered for use in high-temperature applications such as setting firebricks in wood stoves, ovens, kilns and fireplaces, installing clay flue lines and smoke chambers. General refractory masonry where medium-duty performance is acceptable. It is important to note that this is not a castable mix and not intended for mold work, patching or use as a surface coating. It's meant to be used strictly as a mortar filling joint between refractory units. Mixing instructions: add 22 to 28 fluid ounces of clean water per 10-pound bucket of dry mix. Mix thoroughly by hand or with a mechanical mixer for 2 minutes. Let the mix sit for 3 minutes. Then remix briefly before use. Do not retemper once the material begins to set. Working time is up to 1 hour at around 70 Fahrenheit. Application guidance: apply only to clean, sound, slightly damp surfaces. Ideal joint thickness is between 1/8 and 3/8 inches. The mortar sprays easily, holds its shape and bonds well to firebrick. Use a towel or pointing tool to apply and shape the joints. In our test, we prepared the mix in 2 different ways: by hand using a small mixing container, using our lab-grade mechanical mixer. Both methods worked well, and the material behaved consistently in each case. However, if you have access to any type of mixing equipment, we highly recommend using it, even a simple low-speed drill mixer. Why? Because it gives you better blending, more uniform consistency, and ultimately improves the performance of your mortar. According to the manufacturer, the mortar should be applied at ambient temperature between 40 and 100 Fahrenheit. However, it's important to consider how temperature affects curing. At lower temperature near 40 Fahrenheit, the hydration of calcium aluminate cement slows significantly and setting will take longer. At higher temperature, above 100 Fahrenheit, the setting process will accelerate, reducing working time and increasing the risk of premature stiffening. Fobberg's tip: for the most predictable performance and even curing, use calcium aluminate cement-based mortars like this one at 73 to 77 Fahrenheit whenever possible. Curing requirements: keep the mortar protected from rain or moisture for at least 24 hours after application. In colder conditions, use plastic sheeting or thermal blanket to prevent freezing. Once fully cured, the mortar becomes water insoluble and acid resistant. After curing, the material can withstand continuous exposure up to 25-50 Fahrenheit, which is more than sufficient for most residential or light-duty industrial application. However, the manufacturer does not provide a specific heat-up schedule, step-by-step temperature increase instructions. This is important, especially for new installation. So, here's our professional recommendation. Fobberg advice: always introduce heat gradually during the first firing. Start with a low temperature burn or heat source for several hours. Then slowly bring the system to full temperature in stages. This allows any remaining moisture to evaporate without creating steam pressure inside the joints, which could otherwise cause microcracks or bond failure. Strengths: easy to mix by hand or machine. Smooth application and excellent workability. High temperature resistance up to 25-50 Fahrenheit. Acid and water resistant after curing. Ideal for fireplace, stoves, smoke chambers and clay flue liners. Limitation: no clearly printed manufacturer's date, only just a Julian code on the lid. No official heat-up schedule provided by the manufacturers. Not suitable for a castable application or high-load industrial refractories. Bottom line: this is a well-balanced mortar for a residential and light-duty use. If you building or repairing a wood-fired oven, fireplace insert, or a backyard smoker, this product offers reliability, thermal stability, and ease of use at a reasonable price. It's not meant for the harshest conditions, but it performs exactly where it's supposed to. One final but critical point we want to emphasize. Calcium aluminate cement-based refractory products have a limited shelf life. For this particular mortar, the standard shelf life is 12 months from the manufacture date, assuming it's stored unopened in proper conditions. But here is the reality. Many professionals consider 6 months to be the true best performance window for calcium aluminate cement-based materials. What does it mean for you? The fresher the mortar, the stronger the bond, and the more reliable the final performance. Over time, calcium aluminate cement slowly loses reactivity. Using an older batch can lead to weaker bonding, incomplete curing, unexpected failure in high heat cycles. So, if you are sourcing this or similar product, always check the batch code and try to choose the freshest material available. Thanks for watching. This was Andrew Fobberg and you have been watching Fobberg Reviews. See you in the next video.